Let us discuss about the thermometric property. A thermometric property is the property of an object which changes with the change in temperature. Thermal expansion is one of them. What is thermal expansion? Thermal expansion is the increase in size of object when that object is given heat or when that object is heated. We have thermal expansion in solids as well as liquids as well as gases. Now, when we heat a solid expands lengthwise, area-wise, and volume-wise. But in the liquids and gases, when heated, they get expanded or their increase in size is volume-wise, not area or the lengthwise. So we can say that in liquids and gases we have volumetric expansion, in solids we have linear expansion as well as superficial expansion as well as volumetric expansion or volume expansion. In solids we have linear expansion, that is lengthwise, superficial expansion, that is area-wise, and cubical expansion, that is volume-wise. In liquids and gases we have volume expansion only, that is cubical expansion only. Let us discuss in case of solids. Firstly, the linear expansion, then the superficial expansion, then the cubical expansion. The linear expansion is given as the increase in length of a solid when that solid is heated, that is lengthwise. If we take L1 is the initial length, L2 is the final length after heating that solid, and alpha is the coefficient of the linear expansion, then L2 is equal to L1 into 1 plus delta T, where alpha is the coefficient of linear expansion, delta T is the change in temperature, L2 is the final length, L1 is initial length. Now we can see that delta L is equal to L into alpha delta T, where delta L is the change in length and L is the original length, alpha is the coefficient of the linear expansion. Now if we have to calculate what is the coefficient of the linear expansion, alpha is equal to delta L by L delta T, where delta L is the change in length, L is the original length, and delta T is the change in temperature. This is linear expansion. Now talking of the superficial expansion, when we talk of superficial expansion, the superficial expansion is the expansion in terms of the area or area wise. Now if the initial area is A1, the final area is A2, and beta is the coefficient of superficial expansion, then we can have A2 is equal to A1 into 1 plus beta delta T, where delta T is the change in temperature. Now if we take delta A is the change in area, that is equal to A, the initial area, into beta delta T. We have that beta is equal to delta A divided by A delta T. This gives us the value of the coefficient of the superficial expansion. Now talking of the cubical expansion in solids, that is the volumetric expansion, we have if V1 is the initial volume, V2 is the final volume, and gamma is the coefficient of the cubical expansion. In that case, V2 is equal to V1 into 1 plus gamma delta T, where delta T is the change in temperature. If we have delta V is the change in volume, that is equal to initial volume into gamma delta T, from which we can have the value of the gamma, that is equal to delta V divided by V into delta T. This gives us the coefficient of the cubical expansion. The relation between the coefficient of the linear expansion, coefficient of the superficial expansion, and coefficient of the volumetric expansion or cubical expansion is beta is 2 times alpha and gamma is 3 times alpha. Now we can have that alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Expansion of liquids and gases. The liquids and the gases undergo cubical expansion, that is expansion in terms of volume when heated. Both liquids and gases, but the gases expand more compared to solids and the liquids at ordinary temperatures. But we have here all the liquids expand on heating, but we have got anomalous behavior of water. That means from 0 degree Celsius to 4 degree Celsius, when water is heated from 0 degree Celsius to 4 degree Celsius, it undergoes decrease in volume, unlike other liquids which get increase in volume, the water gets decrease in volume when heated from 0 degree Celsius to 4 degree Celsius. Having least volume at 4 degree Celsius. If it has least volume at 4 degree Celsius, that means water has got maximum density at 4 degree Celsius. This is the anomalous behavior of water. Anomalous behavior of water states that when the water is heated from 0 to 4 degree Celsius, it must undergo expansion as other liquids go, but it undergoes contraction from 0 degree Celsius to 4 degree Celsius with minimum volume at 4 degree Celsius. If it has got minimum volume at 4 degrees Celsius, that means the water has got maximum density at 4 degrees Celsius. Now, gases undergo cubical expansion and gases undergo more cubical expansion as compared to solids and liquids at ordinary temperatures. Thank you.